Hello, friends. Good evening. Welcome to ESN Academy. We are discussing about electronics, and this is session 2 of the electronics, and this is a part of our embedded system programming class. And on this session 2, we're going to discuss about electronic component. Last session we discussed about what is electronics, and this session we're going to discuss about electronic components. And they are basically about only, even though I say electronic components, don't think very big. There are only two components. The first component was vacuum tube that we discussed. And let us see a small application of vacuum tube before move to the second component. One of the applications is very easy. Sorry. One of the applications is very easy. That is the vacuum tube. We have seen that it's a grid. Okay. Here, if you apply 0 voltage, this is going to allow no effect. The current is going to glow, bulb is going to glow. That is, you can call this as a on. Now, when it is giving minus 5 volt, then it is going to block all the electrons. So, cathode, anode. Okay, whatever coming from the cathode are blocked by the grid because this is negative, electron is negative, negative repulse. So no flow. So the bulb is going to be off. That means that I can say this as a switch, 0 or 1. You may call 0 volt as 1, minus 5 volt as 0. When I give 0, switch is going to be off. When I give 1, switch is going to be on. It's a very simple thing. But the beauty is, when I give from minus 5 volt to 0 volt, this will act as a variable resistor. Because why I say resistor? What the resistor does, it controls the flow of electrons. If there's a less space, no flow of electrons, 0. I is equal to 0. When I say that there's a full flow, then I is maximum. But in between, if you reduce the gap, then the flow will change between 0 to maximum. That here also same thing. When I apply a voltage, so 5 or minus 5, if you give minus 1, then some electron will go, some electron will be blocked. If you give 0, all electron will glow. All. That's the maximum. Max current. But if you give minus 1, less current. If you give minus 2, lesser current. If you give minus 4, least current. If you give minus 5, no current. So what is happening? This guy is controlling a current. So indirectly, I can say this guy is a variable resistor. Now, the trick here is this. The trick here is this. How to make a variable resistor as an amplifier. Now, let us come to the small thing. I have a resistor. I give 100 volt. I give how much? 100 volt. This is 10 ohm. This is 10 ohm. Then what is the voltage here? Now you know that why I discussed this on electrical session. This voltage divider. If you don't understand the voltage divider, you never understand electronics. The full electronics is voltage divider. Please. What is V naught? V naught is equal to 50 volt. If this one is 20 ohm, then 10, 20, 1:2. So 66 volt. If this one is 5 ohm, then 67, 6.6 means we put 67 volt. 5 volt means 2:1. That time it become 33 volt. Do you understand now? That is when this is 10, 10, 10, 10, 10, 20, 10, 5. The three combination. You need to understand this. This is your problem. Not I cannot explain to you anymore. This I've already explained on the electrical session. Now what I do was I replace this with a vacuum tube. I replace the vacuum tube. I supply a voltage here. Let us assume that I'm applying about 5 volts. Assuming that if I apply 5 volts or minus 5, sorry, minus 5 volt, that time this guy is passing you some current. Assuming that that resistor is, I told you already the previous session, your vacuum tube is nothing but a variable resistor. The resistor you are controlling by voltage now. When I apply 5 voltage, this resistor value is, let us say, 10 ohm. Understand? When I apply 6.6 volt, then the resistor value will come down. That come down to 5 ohm. Sorry. When I give minus voltage, current will come down. So it become how many voltage? 20 ohm. So when I see, understand the grid, when I give more negative voltage, it will block more electrons. When it blocks more electrons, more resistance. Okay. So when I give minus 6.6 volt, then what happened? Or minus 6.7 volt, assuming. When I give minus 6.7 volt, this become 20 ohm. Because this become 20 ohm, your outside become how many voltage? 67 volt. Now you see here, minus 3.3 volt. That time, this will allow more current because less voltage. So this become 5 ohm. The rest will become reduced. When the 5 ohm, the voltage is, outside voltage is 3.3, 33 volt. So understand now how we did. What we did was, initially, without this vacuum tube, we had a resistor. When I apply a 10 ohm and 10 ohm, I got 50 volt. When I have a 10 volt and 20 ohm, I got 67 volt. When I apply 10 ohm and 5 ohm, I got 33 volt because I apply 100 volt. Now, when I have a minus 5 volt, understand? When I have a minus 5 volt, this vacuum tube cathode, this is cathode. The vacuum tube, when I apply minus 5 volt, assuming that this have 20 ohm, 10 ohm. Because it pass only some amount of current. So this become 10, 10. When I apply minus 6.7 volt, it is going to block more. So it's only, sorry, more resistance. 20 ohm. So it become this. Now, when I give minus 3.3, it is going to block less electrons. There'll be more current. That means that less resistance. See, VIR, you should know thoroughly. When I keep the voltage same, when the current is increased, then R is going to be reduced. When the voltage is common, when the current is reduced, R is going to be increased. That's the same concept. How do you reduce the current? Doesn't matter. So they both are same. Electrical and the electronics are same. There's nothing much difference. So in our colleges, we did a different thing. So when I apply minus 3.3 volt, I got 33 volts. See here, this is a trick here. When I say minus 5 to minus 6.7, I change how many voltage? 1.7. There's a 1.7 volt difference. But here, 50 becomes 67. There's how many voltage difference? 17 volt. Same way here, when minus P increased to 3.3, what's the difference? 1.7. 50 becomes 33. How much? 17 volt. So I change 1.7 volt. What changed here? 17 volt. So I call this as a amplifier. I call this as a amplifier. Do you understand this? Do you understand this? If you understand this amplifier, then you are great. You win the game. This is one of the very big component of the electronics. How do we make? So amplifier is nothing but a variable resistor. Amplifier is a variable resistor. What we do is we are using this vacuum tube as a variable resistor. If it is clear, then fine. If it's not clear, let me know. Why it is not clear. See, there's another beauty is there. There's another beauty. If I change the 100 volt to 1000 volt, then this will become, everything become different voltage. Understand? Now it become 170 volt, become 170. So this is becoming how much? 100 times. So the amplification become 100 times. So I don't change the triode vacuum tube. I don't change resistors. I just change the voltage. Now the amplification become increased. This is a tricky one. If you could able to understand it, it's very good. Somebody is doing very good job of going back home and watching the video and asking the doubts. That's the right thing. Because sometimes you may not understand in the class. So effectively, please understand what is happening. Let me put it at the top level, I'll explain this. If I try to explain to the top level, you'll understand. Because we always have a confusion. This vacuum tube or transistor is actually amplifier. They don't amplify. What is happening is like this. Let us have a box. I will tell you that if you give 1 rupee, I will give you 99 rupees. If you give 2 rupees, I'll give you 198 rupees. So what you get here is these two addition. If you give 1 rupee, I give 99 rupees. And what do you get? You get here 100 rupees. If you get 2 rupees, I give 98 rupees. You add here, you get here 200 rupees. If you give 3 rupees, I give 297 rupees. You get here 300 rupees. You understand this? Is it clear? Is it clear?
Sir, excuse me, sir.
Yeah.
Sir, why don't we use a rheostat in case of, because rheostat also it will change the current, no, sir?
Yeah, but you have
Makes
to
a
do
lot
manual.
difference.
You have to do manually control. Nah? You cannot control the rheostat by voltage. Rheostat is called variable resistor. What I'm discussing is all the time is a rheostat. Rheostat is you have to do manual. But I'm getting an electrical signal. So electronics is all about controlling through electronics. I cannot use the rheostat in the case of vacuum tube because this is electronics. This is electrical. Please understand which is electrical. When I do anything manual control, that become electrical. When I become electrical control, that is called electronics. In
Okay.
electronics, I don't ask me to control through manually. I want to control through only electronics. See, actually, you are right. What I'm discussing about rheostat. That is what I'm explaining now. See, what is happening is, what we always think is that I give 3 rupees, it becomes 300 rupees. I give 1 rupee, it becomes 100 rupees. When I give 2 rupees, it becomes 200 rupees. But we totally forget this. Let us assume that in a village, let us take a village, then you will understand. Let's take a village. The villagers have decided to construct a school. They went to a rich person. The rich person said, okay, I'll agree. But one thing, if you give 1 rupee, anybody give 1 rupee, I will give 99 rupees. So school get 100 rupees. If anybody gives 2 rupees, I'll give 198 rupees. The school get 200 rupees. If you give 5 rupees, I'll give 495 rupees. School get 500 rupees. Understand now? But this deal is not known outside. This rich man said, don't tell anybody. So, if you give 5 rupees, the school gets 500 rupees. Understand? No, right now it's assumption, but there are calculation. Right now what happened was, right now what I told was minus 3.3 I took because easy for us. So when I give a less voltage, see, if I give 0 voltage, then there is the grid has no voltage. So all the current will flow maximum. When I give minus 3.3 voltage, it will reduce because it will block some electrons. When I give minus 5, then it will block more electrons. If I give minus 6.6, it will block more electrons. That's the thing. So this is only I given you was just an assumption. But if you want to really do that, then you have to get the triode and do the calculation. That's what we did it. When I was doing a school days, we didn't have a transistor. We were using only vacuum tubes. Later only we moved to transistor. So I had a good experience on vacuum tubes also. Those radios, when I was school days, all the radios, the words or vacuum tubes. So I used to repair the radios when I was studying in a school. That's the way I learned about electronics. So please understand, in a village, they announced, if you give 1 rupee, the school will get 100 rupees. If you give 5 rupees, school will get 500 rupees. So this is called amplification. But the money cannot be multiplied. That means that somebody is giving. Somebody is giving, the rich person is giving. Now in your case, what is happening is, understand here, there is a resistor 10 ohm. Your power supply is giving 100 volt. And there is you are giving here minus 5 volt. The minus 5 volt is changing the resistor to 10 ohm. But the voltage given here is not this voltage, actually this voltage. So power can, see, energy can never be created or destroyed. If you say amplification, that means that your minus 5 volt become 50 volt. That is not possible. I mean, that is not possible. That's against the theory of consumption. Am I right? So energy can never be created or destroyed. Now what you are doing indirectly is, when I give minus 5 voltage, this guy is, if I don't have anything, minus 5 will go to minus 5. But now our man, who, that supply, power supply, rich person is giving 95 volt. So then adding it, it becomes 100 volt. Understand now? That's the exactly thing I told you about amplification. Please understand, there is nothing called, nobody is amplifying. They are changing the resistor. Because they are changing the resistor, you get different voltage. That is what happening. This is the real. This is what every electronic engineer should know. There is nothing called amplifier. That's why we call this as a, the word is very important, signal amplifier. It amplifies the signal, but you give a power. Understand? So don't get confused. Don't get confused that that signal is getting amplified. No, nobody can do that. That's not possible. So this was grand success from 1910 is a year they were realized, even though 1906 and 07, Lee Forrest found that triode. Yeah, that is here. See, your resistor can become either 0 ohm or infinity. For example, if you take a think of it, if you take a diode, the question is very, don't ask direct question. Please ask in power this one to everyone. So otherwise I have to read the question back. The question is, what will be the limit of amplification when it is 100 volt? Okay. The trick here is this. When I give here 0 volt, you get maximum. That means that this is going to act as a on switch. Am I right? That time I have a 10 ohm. I apply 100 volt. The output will become 0 volt. Am I right? If you give 0 voltage, all the current will flow through. So I get 0 volt. When I apply here minus 10 volt, that time they're going to block. This is going to block all the electrons. So this is going to be open. This is going to be open. When this guy is open, then I get here 100 volt. That's it. I don't get, if I give minus 10 volts, I get 100 volt. So when I give here 0 volt, I get 0 volt. That's the way it's possible. So you change the resistor of this device from 0 ohm to infinity ohm. Infinity means off. 0 means on. See, that's why I'm always saying that you come prepared with electrical. So if you will understand this, if you understood the first 4 days class of electrical, that you have to practice a lot to do this. You have to be very clear. If you say that here is a switch, if you apply this one 100 volt, you get 100 volt. You should write it immediately. Don't ask me now. These are all we discussed in the last 4 classes on electrical. The switch is on. I get here 0 volt. This we discuss. If there's a resistor of 10 ohm, then this is 50 volt. We discuss about voltage divider. So now is the issue came. What is the issue? First is like a relay. Yeah, that I'm going to. That the thing is this. What happened? I speak here 5 volt at my transmitting station, my originating transmitter. I convert my voice to 5 volt. But when it goes to the wire for about 100 kilometers, this signal become now 1 volt. I apply the 1 volt to the grid of the what? Grid of the this one, diode, triode, and here I voltage I apply 100 volt. I give it to the speaker. So I don't give the 1 volt to the speaker. I give the voltage. Based on this voltage, the resistor will vary. So this guy get higher voltage. So if your voice changes, here also that amplification will changes. I don't apply this. This is going to as a control. Please understand, this voltage after 100 kilometers of wire is going as a control. What is going to the speaker is this, plus this. So this is what exactly happening. The drop in the wires. See, please, wireless or wire, everything. Ultimately, every medium gives resistance to the, that is what happening in your phone. For example, or your mobile phone cannot go beyond the limit because you have a cell tower. You have a cell tower and your phone, mobile phone, it can reach only that much power. Okay. If it go beyond that, that guy cannot get a signal at all. He get a very minimal signal, then he can amplify. If you don't get any signal at all, then I cannot amplify. So that will be a minimum signal to amplify. That's what's happening now. So that what I'm telling is, here's a air is a medium which gives you resistance. Here wire is a medium which gives you resistance. But the optical medium, that's what you call fiber optic. The light is going as a reflection. There the resistor is very minimal because no other thing. That's why fiber optic, now all our internet are working on fiber optic. Understand? All our internet are, because it goes through the sea, underground sea. The cables from Chennai to, from India to, it goes to Singapore. Of Singapore to US. Think of it. So much things are going under the thing. There's a company which is laying cables on that. So it's all very interesting. That's what I told you now. This whole thing is very interesting field, but unfortunately, we always look for high-paying jobs than interesting job. Forget it. I'm not here to discuss about that. So what happened was, you were both Bell Laboratories and Marconi. Both were trying to need this component because two things. The problem was this vacuum tube first require a heater. That heater need about 115 volts to heat the electrons, heat the cathode, so electrons comes out. Very unfortunately, that's why all the vacuum tube radios, if you open, it'll be always a hot. Another problem is it's a bulky. And third problem is it requires higher voltage. So bulky, it requires a 115 volt here, it become very hot. Then it requires higher voltage to conduct the things. So people are trying to find these two people. But unfortunately, this guy had a big company, Bell Laboratories. He opened a company called Bell Lab. You know that. That's why our great Dennis Ritchie has invented C programming language from the Bell Laboratories only. What the Bell Laboratories did was, they were trying to find a component which is better than this. And they're trying to do a research. They found a surprisingly metal called germanium that has 4 valence electrons, 4 electrons in the lost orbit. And that forms the shape of nice bonding. Forget about this. I'm not studied chemistry even school days. Don't worry. Please excuse me. I never studied physics or chemistry in my school days. I did only maths and electrical. I'm not, you may be knowing much better than this. I'm a pure electronic technical guy. I don't know about physics or chemistry. So this bonding was very good. And there's one more. It goes like that. Okay, all the atoms are having a good bonding. So they get the 8, 1 here, 1 here. So they get 8 electrons. So that is, you know that 8 electrons is the final orbit, is a closed orbit. And each one is attract each other, and they're all well bonding. But since this is a 4, they found a nice mechanism. By adding another metal of 3 valence electrons or 5 valence electrons. Three. When I add 3 with this, I get a hole. That means that there are only 7, because 4 plus 3 is 7. When they have a 5, they become 4 and 4. 1 electron comes out of the bonding. So this is the great invention they found out. So now they call, then they from germanium, they have found that germanium was costly and availability was limited. So generally they found out that this is the same 4 valence electron. It was silicon. That changed the whole world. So silicon, they added with 2 material. One is boron gas, and the other one is phosphor. So phosphor had about 5 valence electron and boron had about 3 valence electrons. I think that's correct. Let me verify that a minute. Sometimes I forget the physical concepts. Yeah, that's correct. So what happened? They have combined these 2 metals, silicon and boron. They have created a new metal called P metal. Because why they call P metal is there is a 7 valence electrons. One is empty. That's what they call P. This is a name. And here I have 5 plus 4. I got 9 That means that I added 8. I have one extra out. They call this as a N material. See, please don't get confused between this N. See, don't get confused between P and N with plus and negative. Don't get confused. These two are different. In this case, this is fully stable. Number of protons and number of neutrons are same. This is also stable. Number of protons and number of neutrons are same. Clear? So whereas in positive and negative, in our voltage source, here number of electrons is less. Here number of protons is more. That's why when I connect them, there's a flow of electron. Correct. But let us say that I have plus and minus. I have two blocks. One is plus and minus. One is P and N. If I connect them like this, the electron will flow here. Because minus means more electrons, less means less electrons compared to protons. Here, when I do P and N, when I connect them, there will not be any current because both of them are what? P and N are neutral, stable. It's not so. Don't ever confuse between P and N, positive and negative, please. But the problem is here. The trick is here. That is what the scientists have found beautifully. That's all. That's all. Always science is a wonderful field. Now, when I have the orbit, which has about 7 electrons, we try to have an electron to make it as a stable one. The same way, the other one, which has 9, 1 electron is out. That can be easily pushed because it's outer orbit, one is becoming a pure conductor like that. It's only one in the final orbit. Now, what they did was they had a P material, they had a N material. But out of the room temperature, this is service enough. Make the electron to move. This electron gets the energy from the outside on a room temperature. So there will be an electron will move. Okay. And they cannot go and get into the electrons of this guy. There's a hole here. Please understand. This guy is having a hole because only 7 are there. This guy is having a hole. That means there's a space for 1 electron to get in. And this guy is having 1 electron away. But both, even though they come closer, this guy cannot go. That requires some energy. That energy, you apply a negative energy here. See that I'm applying negative voltage. I'm applying positive voltage. When I apply the negative voltage here, that guy is pushing these electrons. So these electrons are moving above this metal barrier. That's what you call as a depletion layer. Let us not get into those too much of science. So science, engineering, and technology. We are discussing about technology. I don't even come closer to engineering. I'm not even discussing engineering at all. That is much closer. Science have, see, maths is having 100% maths. Science is having about 80% or 60% maths and 40% reality, physical things. And engineering about 40% maths and about 60% science, or 30% maths and 70%. Technology, almost very negligible maths, and most of them are real, physical things. That's why today we don't need, when I say no mathematics, people think that there's, but actually, when you work on technology fields, you don't require great mathematics things. But very unfortunately, we are taught too much of mathematics. But I'm not trying to say mathematics. Without mathematics, the world will become standstill. But without mathematics, no Maxwell equation, there is no wireless, there is nothing. All mathematics. Everything is mathematics. But to get a good job, to earn a nice life, you don't have to be a good mathematician. Now you see here. So if I apply a voltage here, negative to negative, negative to N, and positive to P, then what happened? This guy pushes the electron, this goes, but at what voltage if you give, then that guy will go beyond the barrier. It will go, conduct and come back. That is called the threshold voltage. That is here is 0.7 volt or 0.6, 0.5, something, 0.7 volt, we agree. In silicon. In germanium, there is 0.2 volt. Now, we are not going to discuss about germanium because of its very low usage in the industry. The silicon, is freely available. All our beaches, everywhere is, I think, second highest metal is available is silicon in the world. That's why we don't, the IC manufacturing become so cheap, except raw material is very cheap. Of course, the manufacturing methodology is costly. So this, if I give 0.7 volt, this makes a connection. If we do the other way, if we do this one is positive and this one is negative, then what happens? These electrons are moving to this direction. And this negative voltage is coming here, getting connected to the thing. So there's a big gap happens here. It's a big gap. So there is no current. When I give positive to N material and negative to P material, then there is no current. So we normally do like this. We put a symbol like this. This is anode. This is cathode. If we give, anode is called P material, cathode is called N material. Let us forget about anode, cathode, P and N. Suddenly, sorry. So now, if I apply a voltage this way, then positive to positive, negative to negative, that we discussed previously, the current is going to flow. This is called forward bias. Now, if I apply here, this way, negative to positive, everything, the other way, then this positive attracts all the electrons. And the negative get collided with the electrons here, collided with this hole. Then this area become empty. So there's no, actually it acts as a switch. So it's called reverse bias. I know that you people know this better than me, because this is what they taught in the college very well. But very unfortunately, this is not going to get you a job. When it maybe the IC plant something comes to maybe, but today the job is required. The other area is very high than this area. So I'm not much concentrated on this area. So please understand forward and reverse bias. If you connect positive to P, it's called forward bias. Negative to N. So, sorry, negative to N. If you do other way, positive to N and negative to P, that's called reverse bias. That means no current. But even the forward bias, you're supposed to give 0.7 volt. Otherwise, current will not flow. It's off. This is, since there are two metals, they call this as a diode. Any doubts on this?
Sir, excuse me, sir.
Tell me.
Sir, in reverse bias, current is there, but it's very negligible. So like it will be in microamps.
Yeah. That'll be a leakage current will be there. Very you cannot do that.
Yes.
But there is a one trick also there. The reverse bias, if I increase the voltage beyond the limit, then the current will start flowing. That's called break even.
Break voltage.
Yeah. If you do this way, beyond every diode, they will tell you that what is the maximum break voltage, break even voltage. That voltage we don't discuss at all now. See, these are all generally on electronic components you discuss. I don't. This is embedded system programming. I'm just giving you the idea of that. But this is very well used, converting, rectifying your AC to DC. Only this will go. This will not go because of reverse bias. That's called off-wave rectifier. Then we do full-wave rectifier. Sorry. I'm not going to discuss about this here. If you want, I can start the analog videos that you can see that. Then we add a capacitor. Then the charges will become like this. So we act as a rectifier, this one, diode. The use. Now, the Bell Laboratories, as I told you that they don't want to use the vacuum tube. They want to find a replacement for vacuum tube. So there were about two scientists, Bradman and another one is Grad. Oh, I didn't get, sorry, that's wrong. There were three scientists working in the Bell Laboratories. They were trying to find, what they did was they've put a very surprise connection. See here, I have a diode, P and N, sorry, N and P. Let me draw this as in black, then you will understand. So N and P. And they had another diode, N and P. The two diodes. Now, if you connect here, battery, these two are connected. What happened? If you connect this here, this is positive and this is N. So this is reverse bias. Whereas here negative to N, this is forward bias. One is reverse bias, one is forward bias. That means one switch is off, other switch is on. So no current flow. Then they have changed the connection here. You understand? Now this is negative to negative. This became forward bias. This became reverse bias. So unfortunately, when they make the connection in the both the way of battery connection, sorry, there is no current. And you know, they are scientists. What they have done was they had applied a voltage here. You understand now? They apply a voltage here. So this is positive and this is positive. And this is negative. This is negative. Yeah, negative. This is N and negative, positive and P. So this became forward bias. The current was flowing like this. Okay. So they were very clear. This is positive and this is N. This is what reverse bias. And this is forward bias. So the current will not flow here. Am I right? The current will not flow here. So a trick has happened. What is the trick? They separately, when they change this current here, they put a resistor and change the current here. Surprisingly, they found the meter. There's a current here. That this is all accident. This is called accident. But of course, the connections are made by them, but they did not know this will happen. Please understand. And they were about to go for lunch. And when they were changing this started changing. This current, God, they sat. That's the way one of the greatest inventions happened in the industry. Okay. It's very simple. I can draw this in another way. NP. Am I right? Diode. Other diode is, I connect two diodes. Of course, I have a resistor. Always to control the current. Otherwise, the device will spoil. If there will be a current limiting resistor, will be always there. See here. Then they said, then they found out that, hey, why don't you remove this? We will make this P as a very nearby. So what they have done, they have connected this P much closer. They could control it better. Then what they have done was, they made the N as a big. They made N as a big. And they made P as a small. Then what happened? This was changing. This they could not control. Then finally they removed this. They made only one P. So they had two N's and one P. By changing the width of the P and changing the N, the current here, let's call Ix, and this call Iy. The Iy by Ix, the factor, they could be able to change it by changing this three materials size. Understand? They finally found out that by changing the current here, I could change the current here. So they thought this is a resistor. And the resistor is transferring the voltage to resistor. Am I right? This component is taking the voltage and controlling it as a, converting as a resistor. That's why they call this as a transfer resistor and transistor. They combine this. You can go and check the Nobel.org site. This invention got the Nobel Prize. The Nobel.org site, they have explained about why they have given a name called transistor. It's not me. It's all, I'm just as a messenger. I'm a middleman. I take the information and give it to you. But the only thing is I'm giving you what is needed only. That's the only trick. So this, they have changed these two together as a single component. This is nothing but a variable resistor. And this one, when I control the current here, Pn, so they made diode. Understand here? It's a variable resistor and I have a diode. So when I change the current here, this current will change. Okay. This, very unfortunately, this could have been a nice symbol. Understand? This would have been a nice symbol to understand, easy for you. You will understand if you draw like this. You will understand better. But unfortunately, they made it as a symbol of like this. That's why you thought this is something. Understand? You think this is great. Nothing. A transistor is nothing but a resistor. A transistor is nothing but a variable resistor. So only there are two components in electronics. One is vacuum tube, which is having a grid as a control. This is vacuum tube. And today we don't use it. That's why I don't discuss this much. It is called after 1980s or not. Today, very rarely somebody uses. But we use this. Transistor is nothing but very simple. The transistor is nothing but three materials. We add N, P, and N. Or there's one more thing is also there, P and P. That we'll discuss later. Let us not worry about that. Right now, we talk about only N, P, N. So, I use silicon. First, understand here. We take silicon, we add boron, we get P material. We add silicon, phosphor, we get N material. Then we add these two, we get diode. Then we add these materials in a fashion called N, P, N. We get transistor. So transistor is nothing but P material, a combination of P and N material. P and N materials are created, combination of silicon and boron, silicon and phosphor. So basically a transistor is created using silicon. Silicon is the base. And what they have, like this one, vacuum tube. This guy is emitting the electron. They call, this is a emitter. This guy is going to give an electron. And this guy is going to control, they call base. And this guy is going to collect the electron, they call collector. See. So please understand, this is what the emitter, base, collector. They were both nothing but a variable resistor. Nothing more than that. So don't get too much confused about this. If you go in detail, that is clear as a history. Don't start using it as a technology. Out of your curiosity, try to understand and learn it. We will discuss about the next session. What are the various types of we have BJT, we have two types, BJT, FET. And in BJT, two types, NPN, PNP. FET, we have so many types. Junction field effect transistor, MOSFET, CMOS, FET, so many things. We will discuss about them in the next session. Because we should know that. See, this electronics topic is only for your knowledge, to know that, hey, these are all there. How from silicon, we go to the chip. But the other one will be another useful, digital electronics. Go and watch. Then microprocessor. Then microcontroller. That's it. These are all, this is the full flow. Electrical, electronics, digital electronics, microprocessor, microcontroller. That's the one flow. Then bottom, C programming, embedded programming, controller programming, embedded system programming, like that. This is another flow. So this is knowledge. This is skill. If you just perfect our normally 64, by this time I'm going to make one more 8 lectures, about 70 to 80 hours of videos. Enough. you can pass through any interviews. You have to practice more. If you once you know the fundamentals and you practice the C programming, nobody can beat you. Maybe today's class might have given you some confusion, but go and watch the video and let me know where you don't understand that. Okay. Thank you. Have a nice day. So any doubt, ask me at any time on the